All right, what's up, students? I am at a little leadership conference today, and so I wanted to drop a video in here, and we are talking about ellipses. Now, I just want to warn you guys, ellipses are tough. There's going to be a lot of moving parts here. So I'm kind of glad in a way that I have a video because you can pause, you can rewind, and I strongly recommend that you do that. I started you off with another Desmos activity where you need to explore. And listen to me, if you skipped over that and jumped straight to the video, it's your loss. Because I promise you, doing this Desmos activity here, it walks you through and gives you a chance to explore like what the moving parts of an ellipse do and what they might look like. You can have long horizontal ellipses like this. You can have vertical ellipses like this, and it really gives you a chance. It shows you what the formula looks like. And notice this looks similar to a circle. It's got the x minus h squared, it's got the y minus k squared, but notice there's going to be fractions. There's going to be a number underneath of each. And notice an ellipse is always equal to 1 every single time. So you get to explore that a little bit. It introduces you to different terminologies, the major axis and the vertices. So the major axis, if it's a tall ellipse like this, if it's tall, then the major axis is that length up and down, and then that point 1, 3 and that point 1, -5, those are the vertices. If it's running horizontally, then these are the vertices, the -8, 2 and -2, 2. So there's some new terminology. The minor axis, that's the shorter one. So for this tall guy, it's the left and right axis. And for this kind of egg-shaped guy over here on the left, it's top and bottom. So you have minor axis, you have co-vertices. It lets you experiment and click and drag. So if you haven't done this Desmos, take your time. And I think you should go and spend some time there. But I am going to start with the notes. Okay? So, ellipses. Let's get some vocab down here. You've got your center. Okay, that's still H and K. You've got your major axis, which is the longer of the two. Yikes. Major axis is the longer of the two. Minor axis is the shorter of the two. Okay, how do you know which one's which? It's if your ellipse is going long ways versus if your ellipse is going up and down. Okay, so you've got what's called the foci, 2 different focal points. Okay, I'm going to put those in blue. You've got focal point 1, focal point 2. Okay, and the definition of an ellipse, it's the set of all points such that the sum of the distances from a point, let's just say there's our random point on the outside of the ellipse, the sum of the distances from the 2 foci, I just drew it in blue, is constant. So if the sum is 12, then this point might be 3 and that might be 9. It's a total of 12. If we were to pick this point right here, it'd be 6 and 6, a total of 12. If we picked this point over here, it might be 1 and 11. But no matter what, it's always going to be equidistant from the point. I think this, take a look at this really short video here of someone drawing an ellipse using string and a marker. Fast forward a little bit. How to draw a perfect ellipse. All right, show us. So notice, those toothpicks are like the foci. Those are the 2 focal points. And these little ends of the line that makes the triangle, notice he sets up his marker, he or she. Go for it. Come on. Okay, see how they're going around? And notice how it's making a perfect oval shape. I'm going to pause it here in a second. So right there, this triangle, it's probably like 6 and 6, right? Total of 12. As they keep going, there's a right triangle. It might be 4 and 8. Over here, it makes kind of a straight line. But look at that shape. That's a perfect ellipse. It's because of those 2 focal points and the line being equidistant as you moved around the center. Okay, So we got major axis. We talked about these two foci, the plural of focus. Now let's get the standard form of an ellipse down. Okay, the standard form looks very similar to a circle. It's x minus h squared plus y minus k squared. But here's the two differences. There are numbers underneath this, and honestly, the numbers can change. So like, here's what I mean. Let's put a squared here and b squared here. But if your ellipse was going to go, if your ellipse was going horizontal like that, then a would be underneath the x value. Because think x-axis, horizontal. So the bigger number, a is always the bigger number. So if the bigger number is under the x value, it's a horizontal ellipse. But if we were to want to make like a vertical ellipse like that, then it would be different. The a would be over here, and the b would be over here. So whichever direction your ellipse is going, that is where your bigger number goes, and that is what your a value is. Your a value is your bigger number. But for the sake of this formula, we will leave a underneath there, b underneath there, and it's always equal to 1. Ellipses are always equal to 1. All right, notice I got ahead of myself. A can be under either term. A is the bigger number, and a determines the major axis of the ellipse. So a determines your major axis. All right, let's talk some ellipse facts. Ellipses are pretty impressive shapes, okay? So yeah, let's actually draw this, just so you know. You could have this, which have its center, focal point 1, focal point 2, or you could have this, which would have a center, focal point 1, focal point 2. The foci are always on the major axis. The midpoint between the two foci is called the center. That makes sense. Center is right in the dead center of the ellipse. The line segment that cuts through the foci and that has two end points on the ellipse, so something like this, cuts through the foci with end points on the end, that is the major axis. Okay, the longer of the two segments is called the major axis. And the endpoints of those major axes are the vertices. So it's almost like vertices of a triangle or something, but these are the vertices. So that would be vertice number 1, vertice number 2. So you've got your major axis connected to your foci and your vertices. What about the minor axis? The line segment that cuts through the center and is perpendicular to the major. I'll draw that in green. So this guy here. Notice it's much smaller. That is your minor axis. Minor axis is the smaller of the two. And the end points of the minor axis are not the vertices, but the co-vertices. So if you're the major axis, then think of yourself as the pilot, right? You don't have to have co attached to your name. You own the vertices. But if you're the minor axis, you're like the co-pilot, right? You're pilot in training. So the minor axis has the co-vertice, we'll label that with CV, and the major axis has the vertices. So last piece, and then we're ready to dive into some examples, is how do we find the foci? How do we know? I'm going to use lime green here. How do we know what this distance is? The distance from the focal point, from the foci to the center. That distance right there. How do we find that? Well, we use a little formula that we're familiar with, but we put a spin on it. We can find the foci by using the relationship between A and B, which is from your major and minor axis, to find C. Okay, C is the distance. If we had to give a definition to C, it's the distance from the center to the foci. That's what C is. And how do we find C? It's a little take on the Pythagorean theorem. Okay, remember from this video that I showed you, I paused it like at one point right there. Looks like a right triangle, A squared, B squared, C squared. Well, it's sort of a spin off that, and I don't want to go too in detail, but just to say that instead of adding the two legs together to get the hypotenuse, you're subtracting them to get the distance from the foci. Okay, so how do we find A and B? Well, remember, A, these are going to be in your formulas. Okay, a squared is going to be in your formula, and b squared will be in your formula. Or if it's not in your formula, then here's the distance. I'll use red. A is this distance here. From the center to the vertice, that's A. So like half of your major axis. And then I'll use green again. This is B. Half of your minor axis. So A is half of your major axis. Honestly, we should just write that. A equals half of the major axis. And B equals half of the minor axis. And then we already told you what C was. It's the distance from the center to the focal point. Okay? Not sure how. Oh, I got 4 minutes, plenty of time. So let's just try one. If an ellipse is not written in standard form, then once again we complete the square. Okay, just like we did with circles. And I just taught that circles lesson today, and we were a lot better with completing the square. It's going to be a little harder now, but I think we're ready. Example 1, find the center. We can do that. The vertices, we haven't done it before, but we will. The foci, yep. And eccentricity, can never say that word, but we're not going to find it, of the ellipse given this equation. And then draw a quick sketch. Okay, so I'm looking at this. I look at this, I quickly glance up to my notes on the formula, and what do I see? I don't see it divided by anything, and I don't see it equal to 1. So, Houston, we have a problem. But we can fix that with one quick solution, and that is if we divide everything by 36. Look what that's going to do. It's going to give us a new equation that I'm going to write right here. 9 divided by 36, that is going to be 1/4, so just have a 4 on the bottom. 4 divided by 36, that is going to be 1/9, so a 9 on the bottom. And 36 divided by 36 is 1. So booyah, now it's an ellipse. So what do we need to find an ellipse? This is like your toolkit. We know we're going to need A, that's our major axis. We know we're going to need B, that's our minor axis. We know we're going to need the center. And we're also going to need C to find our, we'll do C down here, to find our foci, our 2 focal points. See? Center, vertices, foci. So let's start attacking this. My first thought when I see this is this ellipse like going to be one that's like this, like more horizontal, or is it going to be one that's more vertical? And so I look for where my bigger number is, and I see the bigger number. I'll use blue. I see it underneath the y squared. So that means this is going to be taller, think y-axis. It's going to be taller than it is wide. So that is my A. That's my A squared, pardon me. So my A is 3. And then the 4 must be my B squared, so my B is 2. My center, there's no H or K, so my center must be on the origin, 0, 0. It's nice when that happens. And then I need to find my C value. The C value, this is where it's a little just memorization. You use this, okay? You do C squared is equal to A squared minus B squared. So I go down here and I say that C squared is equal to A squared, so 9 minus B squared, which is 4. So C squared equals 5. So what does C equal? The square root of 5. But Mr. Smith, I don't know what the square root of 5 is. I don't know what that distance is. Just estimate. Square root of 4 is 2, so we'll just approximate that that's a little bit more than 2, 2.2. Okay? We got enough to put it all together, and I got 30 seconds to do it. If I don't do it, I'll finish it on the next video. I've got my center, 0, 0. Boom. My A value is 3, so I'm going to go up 1, 2, 3, down 1, 2, 3. My B value is 2, so I'm going to go left 2 and right 2. There is the outer shape of my ellipse. I built that using my major and my minor axis. And then I think on the next video, I'm going to finish plotting my focal points, but it's about 2.2, so here and here. But I got to cut this video off. We will continue part 2 in my next
next video.